Okay, welcome back. We're going to talk about related rates. Related rates, I would say, probably are one of the more difficult concepts that kids struggle with. They can get complicated. Fortunately, I would think that with the business calculus, they're going to stick pretty much with business applications. At least that's my hope, and that's the process, the thought process I went through. What makes them hard is their word problems, and their word problems that involve derivatives. All right, so you just have to learn how to read a word problem is what the people have trouble with. So for problem solving in general, you should read and reread the problem carefully. It's not like reading a paragraph where, okay, I read it once, I'm done, I got it. You just don't work a word problem like that. Read it one sentence at a time, underlining numbers, take it slow, reread it if you need to until you get the gist of what it's asking. You want to identify the variables. So what is it that I don't know? What is it that I want to find? All right, so keep that in mind. You can label a diagram if possible. Number 4, so what I usually do with these is go sentence by sentence, and from the sentence I write an equation or a formula. Okay. Some problems will require one variable and others require more. The nice thing, most problems in this course are going to require you, once you have that relationship, you're going to take the derivative, okay? Or you're going to use the derivative. All right, so after you've taken the derivative, you're going to plug in the given quantities that they gave you, and hopefully you'll get an answer. So the one thing about related rates is you plug in the quantities after you take the derivative, okay? If you do it before, it won't work. All right. Solve the equation and check that the answer is reasonable. This is an important kind of hint for you guys, because if the answer, if I'm getting put $100 in the bank at 5% interest, and in 5 years I pull my money out and I got $1 million, there's something wrong. So make sure that your answers actually make sense. Make sure you have units as well. Okay. So we're just going to practice before I jump into related rates. We're going to talk about how to set up and read a word problem. Okay. So I'm going to read it. First I read it. There are B boys in class. There's 3 more than 4 times the number of girls. How many girls are in the class? So there's 2 sentences. So I'm going to read this one at a time. B boys. All right. So that's a variable. This is 3 more than 4 times the number of girls. So I kind of write it up there. This is, when I find my is, that's usually equal. What is boys? Right. So that's B. 3 more means I'm going to add 3. That's taken care of. Then 4 times the number of girls. So 4 times the number of girls, let's call it 4G. And that's it. And they want to know how many girls are in the class, and then you can solve it. The main problem you're going to have is setting this thing up. Okay? All right, and notice you can only solve this in terms of boys. All right, so the equation I have, the number of boys is 4 times the number of girls plus 3. All right, so let's look at the next one. The sum of 2 numbers is 84. So when I start thinking of that, I'm going to stop there. So the 2 numbers, let's call them x plus y, right? That would be their sum. Is your equals, right? 84. One of them is 12 more than the other. So it doesn't matter what I call it. Let's call this x is equals 12 more than the other. 12 more would be y plus 12. So I have a system of equations here, which is fine. You can plug one into the other, like if x is y plus 12, that goes in here. So I get y plus 12 plus y equals 84. And at this point you can solve it. But the main problem is, can you set them up? All right, so divide $80 among 3 people. So the second will have twice as much as the first, and the third will have 5 less than the second. Okay, so this is a little more confusing, so you have to kind of work through it step by step. All right, so 3 people, so let's call them X, Y, and Z. X, Y, and Z, and I know that they have $80. All right, so here's the first, the second, the third. The second, which is Y, will have twice as much as the first, so twice the first would be X, so Y equals 2X. So I can plug that into there, right? And the third, that's Z, we'll have, that's equals $5 less than the second. So that would be $5 less than means subtract, the second's Y, so it's Y minus 5, right? But if I want to get it all in terms of one variable, you know that Y equals 2x, so that's going to go in there. So I know that Z equals 2x minus 5, so that's going to go in right there. So now I can solve this for Z, and that'll tell me how much the first person had. In fact, we'll go ahead and do it. So if I add up all my x's, I'm going to do that over here. I get 5x minus 5 equals 80. So 5x equals 85. Divide 85 by 5. I'm going to use my calculator on that. I get 17. So I know that x has 17 bucks. Once I have that, I can go back and fill in. The second has twice as much as the first, so I just multiply 17 times 2. And that's going to give me 34. So the other one has 34 bucks. And the third will have $5 less than the second, so $5 less than 34 is 29. Okay. All right, so you want to be able to set these up. Like I said, split them down into their parts, one sentence, one phrase at a time. Okay. So let's look at another word problem. I am recording, right? Pretty sure. Okay. So Jan spent $100 on books. So that's a total. This was K dollars less than 5 times what she spent on lunch. Okay, so this was what, $100. So I know that this is 100 was K dollars less than 5 times what she spent on books. So 5 times, let's call that 5B. K dollars less means I subtract K, right? There we go. She spent on lunch. Oh, let's call it an L. Let's make it meaningful. Sorry, I don't want books. I want L for lunch. And again, you can't solve this equation. You can solve it for L in terms of K, but you can't solve it. If I solve for L, L5, L. So if you end up solving that for K, I can move K over, and I'm going to get 100 plus K equals 5L. Come on. Sorry. Let's see. 100. Let's try a different place. It's not liking that. 100 plus K equals 5L, and then you just divide by 5, and that'll give you whatever they spent on lunch, okay? All right, so the main thing I'm just trying to get at is setting these things up. So let's try another one. This is kind of a business problem. I thought, oh, we'll do one that has a business flavor to it. It costs 90 cents for the Striped toothpaste company to make, package, and ship a tube of toothpaste. That's a cost. The company also has overhead costs of $3,000 per month, okay? The company sells at wholesale cartons of toothpaste at $2.50 per tube. This month, the company sold 5,000 tubes of toothpaste. What is the month's profit? All right. So I'm going to think for a minute. I know that profit is revenue minus cost. It's what I take in minus what I spend. So first thing I'm going to do is look at how much money I take in, which is really right down here, the $2.50 per tube. So the money I would take in would be $2.50 times the number of tubes I sell. We'll call it X, right? All right, so that's the revenue. I'm going to cross it out since I used it. The cost would be 90 cents for each toothpaste. So it's 0.9 times X, right? And I'm also going to take off the cost of $3,000 a month. That's fixed, okay? So that would be equal to my profit, okay? Only one more number to use, 5,000 tubes of toothpaste. What's the profit? I'm solving for P, so X would be the number, it's 5,000. So I'm going to type in 5,000 for X and use my calculator. Okay, so I'm just going to type that in my calculator. All right, and excuse me, I end up with 5,000. So my profit for that month was exactly $5,000 if I did that right, okay? But again, you see how I kind of break it down into little pieces, one sentence at a time, make sure I use all the numbers, and then we get the answer. Okay, so now we're going to add some calculus, all right? We're going to set up this problem without solving it, but it says a 15-foot ladder is resting against the wall. So this is one where I definitely want to draw a picture. Now, if it's not changing, it's not a variable. So like a ladder that's 15 feet, that's not changing. That the length of that ladder is 15. The bottom is initially 10 feet away from the wall. So this is changing. So initially X is 10, but we're not going to plug it in because it's changing. And it's being pushed toward the wall. So we're going this way at a rate of 14 feet per second. Okay, so when they give you a rate, it's a derivative. It has like feet per second, the per whatever. It's so this is a change of, if I call this variable X, this is a derivative of X with respect to time, right? Feet per second. So it's now it's negative 14, which we'll talk about in a minute. All right. How fast is the top of the ladder moving up the wall? So I want to know this. 12 seconds after we start pushing. So T is 12 seconds. We're going to hold on to that. And so we're being pushed up. I'm going to call this Y. And so what we're after is dy dt. Okay. So this is a right triangle. And what I see are three sides. So I know that x squared plus y squared has to equal 15 squared. That's Pythagorean theorem, right? Because that's your hypotenuse. Now, remember the 15 I plugged in because the 15-foot ladder, that's not changing. If it's not changing, you plug it in at the very beginning. All right, now they gave me dx dt, they gave me some time, so I'm thinking I need to do a derivative, which is what I'm going to do. Now I'm going to do the derivative with respect to time. So the derivative of x squared is 2x times dx dt. The derivative of y squared is 2y times dy dt. And the derivative of 15 squared is 0. Okay, now what do I have? Let's see. I have x, right? And I have dx dt. Now let's talk about why it's negative. This is being pushed toward the wall. So do you see that x, this length is getting smaller? So if it's getting smaller, the rate of change is going to be negative. All right, so it's a negative 14. If it's getting bigger, the rate of change is positive. All right, so 12 seconds, and then, so what do I have? I have x, I have dx dt, I need y. Okay, so the way that I'm going to get y, I need to figure out how long. Okay, so 12 seconds, there's a little catch to it. 12 seconds, if this is moving at 14 feet per second, let's see. I know that distance equals rate times time. So it's going to be 14 feet per second times 12 seconds. That's not going to make a lot of sense because I'm going to get a huge number. We'll be up against the wall. So we're going to change this problem. I wanted to see you set it up. So what we're going to say, how fast is the ladder moving up the wall? How about not 12 seconds, but when we start pushing? Okay. So when we start pushing, they told you this was 10, right? And so I need to find this, but I can find this by Pythagorean theorem. So I'll call that y. I know that 10 squared plus y squared equals 15 squared. So y squared is 15 squared minus 10 squared I get 125. So if I take the square root of that, I'm just going to solve for y. I get 11.180. All right, so now I can plug in everything into this equation to solve for dy dt, because what I'm after here, what do I want? I want how fast it's moving up the wall. That's dy dt. All right, so I have plugging everything in. 2x we knew was 10. Dx dt was negative 14. Let's see, what else do we have? The xt was negative 14 plus 2y, so 2 times 11.180 dy dt I'm solving for. All right, so I'm going to move, that's going to be 20, this is just numbers. 2 times 10 times negative 14, I get negative 280 plus 2 times 11.180, 22.36. dy dt equals 0. So you're going to move the 280 over and divide by 22. So let me do that in my calculator. I get 12.52. Let's talk about units. Units of y over units of time. So this would be feet per second. All right, and it kind of makes sense that this is positive because it's going up the wall, so it's increasing, so it should be positive. All right, so that's a related rate problem, but like I said, it's really the same as setting something up. It's just that you have that extra step of needing to take the derivative with respect to time after you do the problem. So I've thrown some business calculus quantities of interest, just things that you should know or I would know. They talk about supply and demand. They use the letter P for demand. P is a function of X, where X is the quantity demanded or produced. Sometimes they'll use Q instead of X for the quantity demanded, so just something to keep in mind. The revenue is the price times the quantity demanded. That kind of makes sense. It's how much I'm selling it times how many I sell. The profit is revenue minus cost. Okay, the word marginal cost, marginal revenue, marginal profit. Whenever you see the word marginal, just replace with take the derivative up. So marginal cost is take the derivative of cost. What it is, it's the cost for producing an additional unit. So if I make 10 units, if I find C prime of 10, then that's the cost of making the 11th unit. The same with the revenue and the same with the profit. It's the revenue earned by getting one more item, or it's the profit earned by one more item. Okay, so the word marginal, derivative. Average, whenever you see the average, simple average, just divide by X. Okay. And so that's what they have here, average cost, and they use a little C bar to represent it. They just divide the cost by X. If they have marginal average costs, the average cost means you divide it by X and then you take the derivative, right? So take the derivative of the average cost. Revenue, again, this would be your average revenue, and then the marginal average revenue is take the derivative of this guy. And same for profit, okay? So average, just divide by X, marginal, take the derivative. All right, another strategy for related rates. Draw a diagram, read it carefully, underline all that stuff, break it down. All right, so one of the things you're going to be interested in with related rates is what is it you're looking for? All right, so that's the first thing. Find what am I finding at what time? And then you want to write an equation that relates the various quantities of the problem. A lot of times you'll be given this with business. We'll look at some examples. And the thing to keep in mind when working these equations, if it's changing, it must be represented as a variable. Things that don't change are constants, like with the ladder above, the length was 15, it didn't change. But if it's changing, it's a variable, and you keep it as a variable until after you take the derivative. All right, so we're going to most likely be differentiating everything with respect to t, and after you differentiate, then you substitute in all your values, okay? So this warning, this is a common error, right, is to plug in the numerical information too soon. You cannot do it until after you take the derivative. All right, so we're going to stick with a couple business applications that I thought I'd go through with you. It says a certain manufacturer found that cost and revenue in 1 month are related by that equation. Find the rate of change of revenue with respect to time. So this is what I'm after. I'm going to underline that. When the cost is changing by $15 per month. So the cost is C, so what they're giving you here is DC/DT, right? That's something you're going to plug in at the end. And the monthly revenue is $25,000, that's your R. Okay, what am I trying to find? I'm trying to find the rate of change of revenue with respect to time. So I'm trying to find the R dt. Okay. So because I need derivatives, I'm going to take the derivative implicitly. So I'm going to work down here. Okay, so I need dc/dt, or I need dr/dt. So I'm going to do the derivative of this with respect to time. So the derivative of C would be dc/dt. The derivative of r squared is 2r dr/dt over 450,000. That's just a constant, so I can just divide by it. And the derivative of 12,000 is 0. All right. So now I've done my derivative. I'm going to go ahead and solve for dr/dt. I'm going to plug in the numbers I have. dc/dt, $15 per month. So that goes right here. 2r would be 25,000. Over 450,000. That is times dr/dt, right? So we're just solving for dr/dt. So 15, I'm going to plug in all these numbers on my calculator. So 2 times 25,000 divided by 450,000. I get 1/9 dr/dt. So to solve for dr/dt, I'm going to multiply by 9 on both sides. 9 times 15 is 135. Okay, so that's what I'm after. Now I just need some units. It's the rate of change of revenue with respect to time. So let's talk about revenue. It's got to be in dollars, right? Yep. So this is dollars per, and then time is month, right? 1 month. It's dollars per month. Okay, so that's your dr/dt. It's going up $135 a month. Okay. So again, keep in mind what you're doing the derivative with respect to what you're trying to find. So given this next one, given a manufacturer has revenue and cost function. So this is your revenue and this is your cost. Given in dollars, where X is the daily production, that's just the number you produce. Find the following when 30 units are produced daily. So what are they giving me here? They're giving me that X is 30. Again, you don't plug in things that are changing until the very end, okay? And the rate of production, let's keep going. The rate of production is 8 units per day. So what is the rate of production? So that's the rate of the number over the time. So it's going to be, this is really dx/dt that they're giving me. Okay. X is the number that I produce. All right, so find the rate of change of revenue with respect to time. So revenue is this equation right here. So I'm just going to do the derivative of it. So dr/dt, you're doing the derivative with respect to time. The derivative of 50 is 50 times dx/dt. Yeah, time minus, let's see, what's 0.4 times 2 is 0.8x dx/dt. All right, so I have X and I have dx/dt, so I can just plug them in. So dx/dt would be 50 times, this is 8, minus 0.8, X is 30, and dx/dt is 8, right? Okay. So I just type it in the calculator. And I get 208. Okay, let's get our units in here. Revenue is going to be dollars, right? per, what's my unit of time? It's days, right? Per day. Okay, dollars per day. So that would be the change of revenue. All right. So the change of cost is actually pretty easy. I'm going to go down here, I guess. So if the cost is 6x plus 15, I'm going to do the derivative now with respect to time. dc/dt equals 6. The derivative of x would be dx dt. And the derivative of 15 is 0. So we know what dx dt is. They gave us that dx dt was 8. So I get 48. So that would be the rate of change of costs with respect to time. So this is dollars per day. All right. Profit is easy because profit simply is revenue minus costs. And we have the rate of change. All right. So, you know, like if you think about it, whoops. Let me put this in here so you can see it. All right. So if profit equals revenue minus costs, if I do the derivative with respect to time, dp dt equals dr dt minus dc dt, but you already have these things. dr dt was up there, it was 208. dc dt was 48. So I'm just going to subtract those two. So I get $160 per day. So you're making 160 more a day, okay, at that point. All right, so I thought I'd show you a couple more business apps. That's what you're, okay, so they're telling you that the price times the quantity demanded is 10,000. All right, so let me go back. So P, oops. So I know that P, the price times X equals 10,000. All right, I'm going to do this derivative. So the derivative, the demand function is, I want to find X. I want to find the rate of change of demand. So what I want is dx dt. All right, so let's do it this way. So if I do the product rule, the derivative of the first times the second plus the derivative of the second times the first equals 10,000. There we go. All right, so dp dt we knew was 20, right? X I don't have yet, but I'm going to figure that out. dx dt I'm solving for, so that's good. We want dx dt, and the price is 420, right? All right, so how do I find X? Well, I know what P is, right? And I have a relationship here, right? So I know that the price times X is 10,000. Oh, sorry, I did a mistake here. The derivative equals 0. Derivative of 10,000, 0. All right, so I'm going to plug in P. 420 times X equals 10,000, and that'll give me X. So X would be 10,000 divided by 420. So I get 2,380.95. All right, so that's going to go in there, and that will give me dx dt. So I have 2 times 2380.95 plus dx dt times 4.2 equals 0. All right, so I'm going to multiply that and move it over. So multiply it by 2. 2380.95 times 2 is, so move negative 4761.90 equals 4.2 times dx dt. So divide that by 4.2 to get my answer. dx dt is negative. I need space, so I'm going to have to go, I can do it. dx dt is negative 1133.79. All right, so let's talk about that. So that's the number in the manufacturing. So if I'm raising my price, it makes sense the number I'm manufacturing, the rate of manufacturing would go down because the demand's going down. So the demand is going down by negative 133.79 toothbrushes per, they don't give us a unit here, whatever the unit of time is. Okay, so, but that's what my demand is going to go down by at that rate. All right, so this last one, it's going to take a little bit, just kind of work through it one step at a time, okay? It says a company is increasing production at a rate of 100 units per day. So production would be the units I make, so dx/dt is 100. Okay, that I got. Second sentence, the daily demand function is determined by the fact that the price in dollars is a linear function of Q. So the demand, what do you want to call demand? Don't they call it P? Let me go up here and check. Is demand P? Let's see. Demand, we're going to go back up here just so I use the same letters they do. Demand is what they call P. All right, P is f of x, the price, quantity demanded. Okay. Let's go back down here. All right, so it says it's a linear function of Q. So the demand, we'll call it P, so that the price in dollars, so that would be the price of the item, right? Okay, is a function of Q. So we need to figure that out. All right, so Q is the X value and the price is the Y. Okay, where Q is the number demanded, I guess, quantity demanded. So at a price of $60, that's my Y, the demand is 0. Okay, so that's 1 point. And at a price, and 100 items will be demanded at a price of 40. All right, so the price is Y, the quantity is X. All right, so now I'm going to stop right there. All right, it's a linear function of Q. That means it's a straight line. So what we're going to do is find the equation of the line between these 2 points. All right, so what you're going to do is remember that the slope of the line is a change in Y over the change in X. In this case, change of P over the change of Q. So if I do the change in P, it's going to be 60 minus 40. That's the change in Y over 0 minus 100. Right, so I get 20 over negative 100, right, which is, I think it's negative 1/5, yeah. So I'll just make it negative 0.2. All right, so that's the slope of the line. Now, I need a point. I can use a point to find it, or I can also use the fact I have the y-intercept. I know that when x is 0, y is 60. So that's my y-intercept. That's your b. So y equals mx plus b, but we're not going to use y. We're going to use p. So p equals mq plus b, because p and q are your variables. All right, so the slope is negative 0.2 times the quantity demanded plus the y-intercept, which is 60. So this is your price. Yay. Okay. So that's that. Okay. Now it says find the rate of change of revenue with respect to time in days when the production and sales are each 25 units. So that's just telling me that the quantity demanded is 25. Okay. I'm not going to plug that in now. Okay. Now revenue. What's revenue? Revenue is price. It's the price that you sell it for times the number that you want to buy. So that's the quantity demanded. We called it normally X. We call it Q here because of the way they defined it. All right. So you have two variables, but you know what P is. P is that. So we're going to plug it in. So the revenue is 0.2 Q plus 60 times Q. I might as well multiply that out to make my derivative taking easy. So it's 0.2 Q squared plus 60Q. I am after drdt. By the way, this is the XDT. This is now, I call it Q, so it's the QDT. All right, so just do the derivative. Oops, I didn't take the derivative yet. So drdt, 0.2 times 2 is 0.4 times q to the first times dq dt plus 60 dq dt. Okay, so I want the rate of change in revenue. Notice that I have the quantity. The quantity is 25, and I have the rate of change of the quantity is 100. So, all right, so we're going to plug it in. So it's 0.4, Q was 25. dq dt we decided was 100 plus 60 times 100. So I'm going to plug that in a calculator. I get 7,000. So the rate of change of revenue by doing that is $7,000 per, to figure out what my units are. What are we talking about here? Per day. All right, so by increasing that, my revenue is increasing by $7,000 per day. Okay, so hopefully this helped a little bit. The idea with the word problems, you know, you got to take them a step at a time, a phrase at a time. You know, everything, every word has meaning. Make sure you use all the numbers, right? Which I did here. Plug in things that are changing. They have to be variables, and they have to stay that way until after you take the derivative. But hopefully this helped. The homework, there's just a Pearson homework. There's 8 problems. Because I knew this would take you a little bit of time, that's all there is this week. And let me know if you have any questions. Have a good week. Take care. Bye.